Hello dear friends, welcome to my channel. Today's discussions is Feynman propagator and Klein-Gordon field. Okay, so friends, those who continuously watching, okay, those who are continuously watching my videos, they have already known that I have published quantum field theory, three fields, where I have already discussed this Feynman propagator. Okay, and I have discussed a lot of topics at a time, and I discussed that vacuum. Yeah, I have discussed vacuum. Okay, so we recall that what is the vacuum. Vacuum I have discussed that. Okay, just recall. Okay, recalling. This is the recalling. Feynman I will prove the Feynman propagator very details. Okay, so because details is important, because students cannot understand very quick discussions. So that's why I create this video only for learner. Okay, those who want to learn Feynman propagator. Okay, details. So in this video you can get a good help for your learning. So now let's start. That you know that annihilated. Okay, that the vacuum 0 by ket 0. Okay, ket 0, vacuum ket 0 by insisting that it is annihilated by all AP. So AP ket 0 equals to 0. Okay, this is the ket 0. Yeah, you can say it is vacuum. Okay, so vacuum definitions I have already told. Okay, and I have told a lot of topics. Okay, those who are interested, please watch that video. That inter three fields, quantum field theory, topic name quantum field theory, three fields. I will also give also uh, description. I also give link. Then you can check it in for your learning. So friends, vacuum you have learned, and I have already discussed Heisenberg picture also. Okay, Heisenberg pictures, a lot of topics I have discussed. Okay, so value distributions, you know that. Okay, the most important topic, that E is equal to EP is equal to P square minus M square. Okay, so let's try to discuss all about things, that P square okay, P square minus M square, P square minus M square. This is the E, or you can say E0 square. Okay. Okay, P square plus M square root over. Okay, this is the important result. Okay, you need to remember. Okay, you need to remember this result. Yeah, very important result. Now we start everything, because it is very helpful for all learner, those who want to learn KGF propagators and Feynman. So my topic is KGF propagator and Feynman. So again recall, I have already discussed it, that phi x and phi y, okay, equals to phi x and phi y equals to d cube p divided by 2 pi whole cube into 1 by 2 ep into e to the power I p x minus, okay, x minus y, and minus e to the power I x minus y into p. Yeah, this way you know, and we know this equals to d of x minus y minus d of y minus x. Okay, very fine and very fantastic. This is the propagator. Okay, so this is the commutator results. These results you know, and we know a lot of results that I vacuum results I also mentioned. This is the recall. I need these equations. This is in red color one, but I need a lot of results. Okay, so some result I just include in here, just remembering that for your learning. Results, which result is vacuum 0 AP and AP P plus I say, but it can, we can say dagger. Okay, AP dagger is vacuum equals to, it can be written P P equals to 2 pi whole cube del 0. Okay, that is a commutator, all the commutator or all the values. And another result is that 0 0 phi x and phi x 0 equals to x x equals to del 0. Okay, so this is the basically you know this result, but we use this but we should remember, because this result is very important, the operator value distributions. Okay, so this way we can learn. And Lorentz invariant measures, I have told everything. Okay, I have told everything in my videos. Now I just show that this theorem you have to remember, and you will get in my operators results. That YouTube name is free fields. Okay, please check my YouTube free fields, quantum field theorem, QFT free fields, where you can get these results. Okay, I have already discussed. Now it is very clear that how I get these portions, the phi x, phi y, d cube, okay, dx minus dyx. Okay, so similarly we know, we have to know. Now I just changing the color, because color is very important. I just change, and that color is which color I will keep? Blacks. Okay, so it is remarkable that we know that 0. Okay, similarly this is this quantity we are going to sandwich it between vacuum. Okay, this we are going to sandwich this with vacuum. So sandwich, so this way and this way. Okay, so this equation equals to can be written simple way, that d cube p divided by 2 pi whole cube 1 by 2 ep. Okay, just using vacuums. Okay, so we get 1 by ep and e to the power minus p x minus y, and okay, minus e to the power I p into x minus y. Okay, so now we just convert it three-dimensional integral to four-dimensional integral, three-dimensional integral to a four-dimensional dimensional. This thing is going to be the Green's functions, as we will see, but it is going. Okay friends, that's you know that I have already discussed. So how we know that? Because friends, you know that propagator I have already discussed. This is the propagator. Okay, in my volumes, that okay, so So this equations is very important for learner. Okay, this equation I apply this equation. Okay, this apply in here. Okay, so you can learn. I will also explain it more if you want. Now you have to remember this is this equations I get. Now I have to you know that these equations, this is the Feynman propagator. This is called 2 pi whole cube. Okay, integrations dp0. Okay, okay, dp0 2 pi I. Okay, 2 pi I e to the power I minus I p x minus y divided by p square minus m square. Okay, so this derives. Now we go to discuss that this derives converted into these derives. Okay, means this is and this is, I have to prove this equals to these equations. Okay, so then I can explain total derivatives. Okay, and in my channel this is the very deep and very proper explanation. Okay, so separate p0. Okay, you have to remember separate p0 in exponentials. Okay, p0 in exponential. So how can I write? Now I go, just change the color. Now I write in here better. Okay, color changing is very helpful for understanding more. So now I can write this way: dqp divided by 2 pi whole cube. Okay, into dp0 divided by 2 pi I. Okay, so I can write this way, and now I write in this way: minus e to the power I px p0, sorry, p0 x minus I. Okay, and I p x minus y. Okay, so this way I can write dp0 p square minus m square. Okay, let me finish. Now you have to remember that p square can be written, p0 square. Okay, p0 square minus norm of p square. Okay, so this property I apply in here. Not this is means m. Okay, so I can write this way that dq p divided by 2 pi whole cube into dp0 divided by 2 pi I minus e to the power ip. Now friends, apply this topic, this value. So I get e to the power p0 x0. Okay, x0 I can write this way. Okay, okay, this way, that is the x0 and y0. Okay? Y0, so I can write this way: x0 minus y0 and plus ip p x minus y. Okay, so divided by p square p0 square minus p square minus m square. Now dp0 means, now again I will discuss that ep equal to, what is the meaning of ep? Ep meaning is equal to p square minus m square. Okay, we know that the energy is going to be the square root of the p square plus m square. Okay, this is the meaning. Okay, so we can write this way Again, we can write this way, very simple way, that d cube p divided by 2 pi whole cube, okay, into dp0 divided by 2 pi I and minus e to the power minus p x0 minus y0 plus ip into x bar minus y bar divided by p square minus e square p. So this way I can write now, this is the p0 square. So I can write this way, that simple, very simple, that d cube p divided by 2 pi whole cube, 2 pi whole cube into e to the power ip p x bar, okay, minus y bar, just okay, just performing a complex in integral and okay, residue theorem. I have to use residue theorem. So I just write exponential part in here, and now I can write dp0 divided to minus e to the power minus p into x0 minus y0. Very simple. And p minus ep and p plus ep. So this way I can write, and now I use residue theorem. So residue theorem, you know that Cauchy residue theorem I have already discussed in my complex analysis. To know complex analysis, they can check. Again I will discuss that it can be written 2 pi I, okay, limit z tends to zn, okay, z minus zn into fz equals to closed integral dz into fz into z minus z cube, okay. So this is the way. And here singularities, now the singularities poles or singularity poles at equals to plus minus ep, okay, poles is plus minus ep. So now there is a lot of case in contour, okay. Case 1 I will discuss everything, that so we have to choose a closed contour, okay. So how can we choose? There is a lot of possibilities in here in propagator, that you see that phi x, yeah, whatever you see that phi x and phi y, okay, commutators, yeah. This value I have already write. This is this way I have written. This is also that commutative. This is the note, important note I have already mentioned in my channel, that phi x and comma phi y can be written as d of x minus y, okay, no problem, no issue, and d minus y minus x equals to 0 when if, okay, x minus y whole square less than 0, okay. I have already told, but I think that you forget, yeah, this portion. This is the property, okay, recall. So we see that 4 momentum, yeah, in here we see that 4 momentum is 4 momentum in this portion. Yeah, in here the Feynman propagator, we see the four momentum, the p square minus m square. Okay, so we need to view the size. I just changing the whatever I have done. Please check the total font. Yeah, total work. You need to know. Yeah, most more changing. You will check that I just used the formula dxy dy, and I just remembering some result, which result I used in here, and again you get that I have to prove that this equals to this. Yeah, equals to this I have to prove. Now I am just starting from in here. This is my work, and now I will go the Feynman property. Yeah, the residue of the force is equal to, I have already discussed that residue of the pole means p0 pole means p0 pole equals to this is. And now you have to remember that when in this case, okay, again I just change my color. Color should be green. Okay, so again I just changing that. You know, you have to remember that when x0 0 is greater than y0, okay, greater than y0, we close the contour in the lower half plane. Okay, we close the contour lower half plane. Okay, not upper half plane. Yeah, no problem. So then we get p0 is equal to p0 equals to tends to minus infinity I infinity. P0 tends to I infinity. Yeah, minus I infinity, and integrating vanish. Okay, integration is vanished. Okay, suppose I write omega, so integration omega is tends to 0. Simple, it is vanishes, ensure the vanishes, and the integrate over p0 picks up residue p0 plus ep. Okay, p0 plus ep, which is okay, minus sign arises. So minus sign arises because we took clockwise contour. Okay, so this is the main property. So close we will consider the contour that includes both poles and closes down. This gives us retarded propagator. Okay, this way we can get contour. This is my contour. Okay, and this is my point. That point is EP and minus EP, and this is the EP, and this way and this way. Okay, so whatever I get p0 equal to minus I epsilon plus EP, and another is p0 equal to minus I epsilon minus EP. This is the two ports. Okay, two ports of the contour. So let's take closer look so we know what p0 is. So I can write this way, that d cube p into e to the power I x minus y. yeah, into p divided by 2 pi I, okay, 2 pi I into dp0 divided by 2 pi I e to the power ip into x dash minus y dash divided by p0 ep into p0 minus ep. Okay, just apply a residue theory. So e to the power ip0 can be written as, now e to the power ip p x0 minus y0. Okay, so it can be written as e to the power minus I, and p0 can be written as real p0 and plus imaginary p0. So and into x0 minus y0. Okay, so this way now I can write e to, and imaginary part can be e to the power minus epsilon x0 minus y0. Okay, this is convergence. This is convergence only x0 greater than y0. Okay, so this is my conditions. Then I have already told that x0 greater than y0, then it is convergence. Now and in quantum field theory, you just remember this is the C number functions. Okay, this is C number functions. Okay, you need to know C number function. Okay, so this is my total work. I hope you can understand. Now I just try to discuss that when I use residue theorem, using residue, yeah, usage 100. Okay, so let's move. Yeah, okay, so whatever we get just use dp. Okay, dp0. Okay, and e to the power minus ip0 and x0 minus y0 divided by p0 plus ep into p0 minus ep. So this way can be written, and I just use residue, so it is 2 pi I limit p0 tends to infinity, limit p0 tends to ep. Okay, so limit p0 tends to ep. So whatever we get this, but I know that my channel viewers are very smart in complex analysis, so I don't need. So we get in here p0. Okay, p0 plus ep. Okay, complex residue theorem, and plus limit and p0 tends to ep minus, okay, minus ep. So we get e to the power I p0 x0 minus y0 divided by p0 minus ep. Okay, so this is the fine. This is very simple. Now we get this equation that 2 pi I e to the power p0 tends to ep0, so I can write ep x minus I divided by 2 ep. Okay, so very simple. And another is e to the power ip I ep into x minus y divided by 2 EP. Okay, so this way we get. So now next we get we can get this way, that okay, P0 is equal to EP. Yeah, simple. Then we are just plugging this value in here. Yeah, 25%. Yeah, plugging the size. You can check, this is the plugging. Simply plugging the size. Okay, 25%. Yeah, more than 50%. So simple plugging in here. Okay, this value I have already, I got this value. Yeah, just plugging this. So we get that integration by 2 pi whole cube into -1 2 pi I into e to the power ip x minus y. And I can write this way, that 2 pi I, just plugging the values, that e to the power I ep into x. Okay, this is the x0 y0 x0 y0 x0 minus y0, and divided by 2 ep, and we can write this way, and plus e to the power minus I ep into x0. So this way I can write. Now I can write this equation just this way, that ep terms is vanishes. Then I can write this way, that integration dqp. Okay, and now it can be written 2 pi whole cube and 2 pi I y plus I p0. Okay, ep is equal to p0 x0 minus y0 divided by ep okay, 2 ep, where p0 is equal to ep, and okay, p0 is equal to minus ep I x minus y. So p0 equals to minus ep, p0 equals to ep. Okay, so this way I can get. Yeah, so this way I can get. Yeah, so now you see that -1 is multiplied. This term, okay, this term, yeah, could be written, this term could be written as p x comma y. So I can write this equation in this way, that dqp divided by 2 pi whole cube is equal to 1 by 2 ep into e to the power I xy x minus y into p. Yeah, now I just remove this, and I get again that e to the power minus e to the power I, that value is minus ip x minus y. Yeah, so I exactly proved this proposal. Proved. This is my proof. Okay, you get already the results, that this value, if this value equals to this value, is proved. So I hope it is clear. that every steps I have already discussed, that when it is convergence, when x0 greater than y0. Now I can write this operator this way, that dr, okay, dr x minus y, and where x0 greater than y0, and this, and phi x greater than y0. Okay, so that can be written as capital theta x minus y, and capital, this is a sandwich. Okay, capital theta comma phi y, and this way, because capital theta is equal to unit steps. Suppose this is the graph, and this is the this way. Yeah, this is the unit functions. So 0 and another is 1. So now I just apply KGF equations. Okay, now I go to KGF. So KGF equations, you know that what is KGF equation? Del square is equal to del square plus m square equal into dr. Yeah, so whatever I get, yeah, x minus 1. Now, and another is the value is 0 phi x comma phi y, including this way. So this is the KGF. It acts on the propagator. So let's do it whatever. Now we use this property, that del mu into del mu is equal to del square. Okay, so we can write this way, that del mu into del mu. Okay, it is okay, del mu and capital theta x minus y. Okay, there is a x0. So whatever I get this value is equal to 0 into phi x comma phi y into 0. Okay, so now we see that it can be written another way, is theta. Yeah, this is the theta x0 minus 1, this way, del mu, okay, 0 phi x comma phi y is 0. Okay, so this way I can write. Yeah, I hope you can understand the del mu, the simple derivatives. Okay, and m square I can write same way, m square into capital theta x0 minus y0, and this is the vacuum sandwich. Okay, this is called vacuum sandwich. So phi x into phi y, C number in quantum mechanics I have already told in my channel. So now I just try to changing the color, because for your better understanding. So we can write this way, that del mu into del mu is equal to del square. So it is del square capital theta x0 minus y0 and 0 phi x comma phi y. Okay, so this way, this is the vacuum sandwich. Another is del mu another is del mu capital theta x0 minus y0. Okay, x0 minus y0 del mu 0 phi x comma phi y. Okay, this is the vacuum sandwich again. And now again I just do del mu capital theta x0 minus y0 into del mu 0 vacuum sandwich phi x comma phi y into 0. Okay, so just changing the color for your better understand, that plus capital theta x0 minus y0 del mu 0, okay, is phi x comma phi y. Okay, so this is the 0. So we get the value is m square theta x0 minus y0. Very large lengthy equations. If any miss any error, please. So let's see how many. 1 2 3 4 5. Okay, 1 2 3 4 5. Yeah, this is the. Now we will go green terms. Green terms appear two derivatives basically of this theta, but now keep in mind theta x0 minus y0 is only function of time. Okay, theta x0 comma y0 function of time. Okay, function of time. Now we have to remember that del square t minus nabla square into capital theta x0 comma y0 can be written as del square t capital theta x0 minus y0. Okay, and minus nabla square capital theta x0 minus y0 is 0. So I can write that del square t into capital theta x0 minus 1. Next, this is the delta functions. Now it can be written as this way, that delta del t into del x0 y0. Okay, so this way. And now C terms. Now I go C terms. I discuss C terms. C terms is that del t capital theta x0 minus y0 equals to into del t now C terms is del t. Okay, del t and which vacuum sandwich. Okay, this is the vacuum sandwich phi x, phi y, that is the commutators. Yeah, so minus del 0 phi x and phi y 0. Okay, vacuum term. Yeah, so this is the way. And now these positions, this term is zeros. Okay, so remember, whatever we did, remember that del mu is equal to del t into del t comma del and del nu equal to del t comma minus t. Okay, term is it, you have to remember. So this term you have to remember. So this is my remembering term. Remember. Okay, so this term is remember. You have to remember this term. So as we remember this term, so we get that this value plus into del t del t capital theta x0 minus y0 and del t 0 into phi x comma phi, yeah. So this way, and plus, sorry, not it is plus, okay, del 0, yeah, phi x comma phi y 0. Okay, so this portion is cut on with these portions, okay, as it is plus and it is minus, yeah. So now you check that this value can be written del t high x. Now we get this value that del t high x equal to conjugate momentum pi x, yeah, okay, conjugate momentum, and commutator pi x comma phi x. This commutator I used a lot of times. Check my videos, quantum fits here. Here also I mentioned these commutators, okay. So this portion, so now this is the results. So these results I get, so this is my important to know, yeah. Now I get these total equations can be written as 2 del, okay, so del t theta means 2 del, okay, 2 del t theta means 2 del into x0 minus y0, and we get the value is equals to 0 vacuum sandwich del t phi x comma phi y this way, and this way we get, and we get this value equal to 2 del x0 minus y0 0 del t phi x means capital pi x conjugate momentum phi y. Now this value is del cube x minus y, so I get the value is minus 2 del cube into del means del to the power 4 into x0 minus y0, okay, into I, okay. Now another term is purple term, yeah. Sion terms I have factors. Sion terms I can write in equation number 1 or 2 anything. So now I use purple's term. So purple terms is capital theta x0 minus y0 into Klein-Gordon equation del square minus plus m square 0 equals to 0. So plug and back in. So I just plugging this value. Yeah, this is my, now start my view. Yeah, more precisely. So del square minus m square dr is equal to, this is the values I got. Okay, I got total value. So whatever I get, so my value is del square, yeah, del square plus m square into capital dr x minus y. Okay, this total four terms can be written as del t into del x minus y, and we get another is 0, these portions. Okay, so we get 0 into phi x into capital, okay, phi. So this value is 0. Another term, this is the remaining term, is minus 2 to del to the power 4 x minus y into I. Okay, now del dash fx equals to minus del f dash x. Okay, so this value can be written as, I just using the result, and I get minus del x0 minus y0 into minus I into del q del to the power 4 x0 minus y0. So Feynman propagator arises as a special contour. So half contour of what we have already done. Now friends, I understand, and thanks for watching. For proper view, I just change my size, and please check my total work. Total work, very lengthy work, but I hope that I can, my effort is meaningful, not useless. Yeah, thanks for watching.